Theo. Welcome to join our QSAN Day 2021. In this session, we are going to talk about the storage performance, which is one of the most important concerns to our customers. In QSAN, we see more and more different application requirements like media production, virtualization, database, cloud, and edge computing. One common feature for this application is that they all need high-performance storage to make all services run smoothly. As an enterprise storage, data assets come from not just one client. These assets may come from different clients. And during busy hour, many clients will even access to the same storage at the same time. What would happen if the storage cannot reply to every client's request on time? You may expect that some clients will get delayed while the others are running smoothly, taking most of the storage bandwidth. But in fact, this is not what will happen. I can tell you what would happen. The storage will get stuck at some point, and all clients will face the same delay situation. From this example, we can see the storage must be able to handle many requests at the same time, and therefore needs well-designed storage software and a powerful CPU to make it happen. We've been choosing Intel processor for the past 10 years as our storage core. Intel processor is reliable and provide excellent processing power. Different selections are available, ranging from low power consumption to ultra-high-speed computing processors. It's very easy for QSAN to select the right CPU solution for different kinds of business requirements. Throughput is no longer the only thing that matters to a storage. Two other important factors that define the performance of a storage are IOPS and latency. IOPS is about how many data requests the storage can handle in a second, and latency is about how quick a storage can reply to a request. For example, many companies start to apply virtual desktop infrastructure for their employees to work remotely. People will log into a single virtualization station to start their everyday job. So many data requests will happen at the same time. That means the storage behind the server will face heavy workload and must be able to satisfy these different data assets at the same time. In this situation, only a storage that delivers high IOPS and low latency can satisfy this kind of application. In order to meet this type of application, we developed our own storage engine, and we find out that Intel Xeon Scalable processor is the best match for us. Combining Intel Xeon processor's computing power and our in-house storage engine, our storage can handle more than 1 million requests at the same time. In our lab, we can even produce near 2 million IOPS at the same time. Storage efficiency is another main challenge for companies, as big data like massive backup streaming file come into your data center. How to smartly utilize the storage space is becoming another important concern for customers. QSAN provides advanced inline deduplication and compression to reduce the storage space usage and lower the budget for our customers. Deduplication technology will get rid of the duplication part from the incoming data, and compression will compact the data as much as possible. Only very strong processor can handle this ultra-high computing request without suffering the performance. With Intel CPU's strong computing power, our storage can easily perform this complicated algorithm without sacrificing the storage performance. Next, we'll show you by using Intel CPU how QSAN can deliver remarkable storage performance to our customers.
Hello, my name is Ethan, and I'm the product manager from QSAN. Thank you very much, Phil, for the inspirational introduction to our solutions. We have seen the importance of performance and software features, and we have also learned how the CPU is critical for driving all these computing tasks. Now, let's move on to how Intel processors carried out outstanding computing capability. With their help, QSAN storage achieves remarkable performance, which helps our customers in various application scenarios. The product lines of QSAN vary from simple SMB NAS, dual controller NAS, storage attached network, to all-flash arrays. We use a wide range of processors on these devices to drive multiple computing tasks. For example, virtualization is one of the most demanding tasks, in terms of latency. A virtualized environment abstracts computing resources and allows multiple virtual machines to be run at the same time. If the head server suffers from latency, the efficiency of the entire system goes down. In other words, if the system fails to execute the computing on all the virtualized desktops, users would be forced to stop their jobs and wait for the connection. That's how time gets wasted. So here's the key. The head server requires powerful computing capability to support massive deployment. And the key to achieve this is keeping latency measures low. On QSAN all-flash array, latency is shortened to millisecond level, and the performance is beneficial for demanding workloads. Let's find out some data concerning the performance of our all-flash array. In this case, QSAN device performs 70,000 IOPS under latency of 1 millisecond. For the scenario of virtualization, the number reaches implies the capability of deploying virtualized machines. In addition to performance, stability also matters. In real cases, we observe high traffic on Monday morning because after a weekend, staffs in a company usually log into VDI in a short period of time. To face such challenge, our all-flash array has undergone performance tuning for extreme workloads. Therefore, it still achieves 35,000 IOPS under low latency. We may conclude that, from the test result, the system remains stable no matter how much computing resource is occupied. Powerful processors drive the performance to meet the requirement of virtualization. How about other scenarios? In fact, computing capability benefits more than high-level applications. Even tasks seem as simple as backup is driven by CPU. Many enterprises adopt NAS approach for backup appliances, and on QSAN NAS devices, software features such as deduplication and compression in large logical space. That is to say, it is computing that maximizes the capacity for usage. Compression refers to the process of encoding data with fewer bits than its original representation. In the files, repetitive and redundant patterns often occupy a large portion of logical space, and they cause poor efficiency of storage usage. Reducing wasted space would help enterprise with saving notable capacity and therefore notable budget. QSAN storage uses unique compression mechanisms to make data transfer faster. Traditionally, compression targets on data stored in the pools. In this way, the system would consume extra computing resource on dealing with those data. On our platforms, compression is conducted on the path of data input and output. In other words, data gets compressed before written into the disk or pool. Once data feed comes in, it is compressed on memory. Then lighter data moves on to be stored in the logical space. Have you noticed the difference? QSAN writes less data into the disk, and that's why our storage runs faster and larger. On QSAN storage, users may experience seamless data service driven by computing capability. Virtualized environment could be efficiently deployed with the low latency, while the duplication and compression effectively exploit the existing capacity. On storage, workload appear more demanding than simple input and output. The computing capability carried out by the processors makes QSAN storage more than an external storage device, but an all-in-one platform for data services. Now, let's welcome Anthony to tell us about how our core technologies help our customers in real cases.
Fantastic sharing from Phil and Ethan. However, people may say, how can I balance the resource usage between data saving and high performance with low latency? The CPU computing and memory usage are shared mostly for these two purposes. In theory, one gets higher, another gets lower. That's fine. No worries at all. With QSAN solution, the unique design of QSAN's dedupe and compression help you here. Both functions won't occupy the CPU resources a lot. On the contrary, reduce the overall written data after handling from the memory area. Actually, performance will even get higher once the dedupe and the compression are enabled. In the installation we deploy in Pittsburgh, the QSAN units deliver extraordinary performance and capacity, enabling them to meet the district's present and future needs. Moreover, QSAN maximizes their budget by purchasing all 4 devices for less than what a single unit from a major vendor would cost. The district mentioned above benefits from ultra-fast all-flash array with its installed flash drive. The customer effortlessly stores logs and data from all devices. They quickly pushed out apps like the in-house student information app, virtual desktops, and the business system. Users are delighted that they no longer have to wait for clients to load or for reports to be generated. Also, thanks to SQSAN storage, the district has strong data protection. One located across a street from the district's high school data center backs up production data, eliminating monthly services costs. The second, located off-site, stores replicated data for disaster protection. They were confident that QSAN storage system would provide high-speed performance and capacity, but they were pleasantly surprised how affordable they are. Thanks for your attention, and always feel free to contact us if you would like to know more about QSAN solutions. We will be very happy to hear from you in the following sessions.